Hallo, hallo? Hallo. Start.
We have to start on time. This event will be broadcasted. Hello?
Ja.
1, 2, 3. Doch, doch, er kommt. Ich glaube, draußen noch lauter. We will start in a few seconds.
That's on the. Okay. Perfect. Okay. Oh, that's it. Okay, so if we can ask everybody to please take their seats so that we can start punctually. Well, good afternoon. Good afternoon to everybody, and also if you're looking in live from YouTube, good afternoon to you as well. Thank you for joining us for our session, which is quantum computing and digital sovereignty, building secure and independent IT infrastructures. Now, we know that quantum computing is rapidly evolving, and it's promising profound transformations in IT security and digital sovereignty. Now, this expert roundtable is going to gather leaders specializing in cybersecurity, cryptography, semiconductor technologies, enterprise software, and quantum research. Hopefully, more than hopefully, we are going to, aren't we, gentlemen? Yes. We're going to explore some practical strategies for building quantum-resistant IT infrastructures and strategies for post-quantum cryptography migration, highlight initiatives aimed at securing sensitive data against quantum threats, such as the harvest now, decrypt later approach, and discuss Europe's roadmap towards digital autonomy. Now, we hope that as a takeaway, all attendees will gain clarity on Europe's strategic response to quantum challenges and learn how to prepare effectively for this upcoming quantum era. Our representative companies and organizations today are from Infineon Technologies, semiconductor manufacturer specializing in security solutions for hardware, for post-quantum cryptography, and PKI migration. They're represented today by Dr. Detlev Hudor, Senior Director Business Development. Next to him is SAP, a leader in enterprise software with expertise in entitlement management systems, EMS, and their integration with secure licensing solutions. Represented today by Thomas Depoveg, Chief Product Manager, SAP Deutschland SE & Co. KG. You see my 30 years in Germany haven't gone amiss being able to pronounce that. Next to Thomas is representative Karlsruhe Institute of Technology, KIT, not KIT, KIT. A research institution via Castel Security Research Labs, advancing post-quantum cryptography and quantum technology research. Represented today by Professor Dr. Jörn Müller-Quade, Professor for IT Security at Karlsruhe Institute of Technology and IT Security Chairman at the Institute for Theoretical Computer Science. And last, but by no means least, our host today is WIBU-SYSTEMS. As you've probably heard, a specialist in software protection and licensing, integrating post-quantum cryptography into solutions like CodeMeter for Secure Monetization, and represented by CEO Oliver Winsenreed, who's also the founder of WIBU-SYSTEMS AG. Now, if you're actually watching online, then you are able to submit your comments and your questions. They will be passed to me, and I can also propose them to the group. So, without further ado, let's begin. Let me start with Jörn. Question for you. It's a question that gets asked a lot these days. When do you think quantum computers? When do you think we will have quantum computers with sufficient power available to crack today's asymmetrical cryptography?
I think I have two answers for that. One is when I expect them to come, it might.
1, 2, 3.
When I'm actually expecting quantum computers to come, there I'm a little bit pessimistic because there are huge challenges. But we've also seen great breakthroughs lately. So there's a risk that quantum computers could be there in, say, 10, 15 years if it continues like this. I would say the risk of that happening is maybe in the single-digit %. But that's a risk we cannot take because, as you said, we have this harvest now, decrypt later. And so even if it comes in 20 years, it's still a threat for the secrets we have today. And actually, there was a time when people thought that quantum computers would be impossible because those quanta are too fragile. But then quantum error correction was invented and it became possible in principle. And now these error correcting codes are being implemented. So it's really, we are on a track, very successfully on a track to realize quantum computers. And I think we should keep this in mind that we have to go to post-quantum cryptography because we will not be safe anymore in the next 10, 15 years.
Well, let's just stay with you there. I mean, if some of the current algorithms will be broken after a few years and need to be updated, how do you feel about this constant updating? And what does that mean for the design of products?
I think that's a necessity because we saw that there were isogeny-based crypto systems which were thought to be safe against quantum computers, but they were later broken on the laptop. So this shows that we do not really fully understand this post-quantum crypto assumptions if problems are truly hard. And so we cannot just jump to the next best solution, but we have to be very careful when changing. First, it's recommended that maybe the next systems should combine the established, not quantum safe, crypto with the new schemes such that you combine the best of both worlds. But also we have to use what's called crypto agility. We have to design the products in a way that you can safely exchange the crypto. And for example, the digital signatures you use to sign the updates, those should be quantum safe in the nearest future because this is what you really rely on when replacing your crypto.
Let me pass that over to Detlev. I mean, you've heard Jörn's comments about the timelines and what have you. How does somebody like Jörn's timeline affect your hardware development strategy? And, you know, what does that mean?
From the semiconductor point of view, you are looking for some guideline from public authorities. So first of all, we have recognized 2017 that NIST in the United States, which is the father of elliptic curve of the RSA encryption, have started the standardization on PQC algorithm 2017. Last year, 2024, we saw that the standardization comes to a first milestone, that the first algorithms are published, communicated, some are moved out of this process, and now we have the situation that the standardization comes to a first milestone plan. Then we have heard from the Commission, European Commission, springtime last year, they implement a European dedicated working group to create the European PQC roadmap. This was published now 2 weeks ago. The European roadmap. The UK roadmap is in the same timeline, and the US roadmap is exactly the same timeline. And from the industry point of view, if you are looking for critical infrastructure for public procurement, we must follow exactly this timeline, what you see in this picture. And this was our intention also to make a first try last year, 2024, to bring some first algorithm from the NIST standardization into a real hardware, into a real accelerator, and combine, as Jörn mentioned, conventional ECC accelerator plus PQC accelerator on the same hardware platform. And December last year, we got the first BSI certification product, certification from the BSI. It's a learning journey for TÜV, it's a learning journey for BSI, and it's a learning journey for us, how long this needs and what kind of new technical area comes down the road. And last sentence, the deadline for critical infrastructure in the United States, UK, and Europe is 2030. This is what they have announced. But the procurement in the United States starts in 2027. This is in 2 years. So then at this time, traditional, conventional, certified, secure products can be not more sold. And this is, from our point of view, very challenging for the industry, because we are starting from the semiconductor, we must go to the software application, we must go to the real ecosystem application. That means we must start first, but we need all the other stakeholders along the value chain.
Okay. Let me pass that over to you, Oliver. Why is PQC so important for licensing?
Yeah, licensing makes only sense if the deployed licenses are secure. Otherwise, all these efforts are lost. And if you are looking on existing products, you cannot immediately changing everything. But the license deployment process, the license creation process, must be PQC secure very soon. Otherwise, what's happening, device manufacturers or software vendors put a lot of energy in doing a flexible licensing for their product, and then third parties are able to create license generators that can issue licenses in a correct way. So the original product will work with a license issued not by the software vendor or device manufacturer, but by the illegal third party that is able to create that. So having a secure license creation, license deployment process, that's the first priority and the first step in upgrading to a higher level of security.
Let me just jump back to Detlef there. In some domains, PKI infrastructures are in use. Now, why is the inventory important as a first step for migration from conventional to PQC encryption? And what would be the next step after?
We have learned that large companies, I explain that later, have not one IT system, they have different IT systems developed over a long time, a long period. The German high-speed railway company, for example, have such kind of different IT systems developed over time, and they must first have a look what kind of PKI is behind, what is the age of the PKI, and what is the criticality for such kind of hacking. Airbus makes the same analyzing for the Airbus group. Yeah, it means you have different domains, you have different divisions, and each of them have their own, you can say, IT system, and also for aircraft, for military, you have also different development paths, and they must also have this kind of analyzing what's existing. Second point, before you start any kind of changing in the front end, you must start with the back end. And PKI infrastructure is the first step, which must then support the old crypto keys and certificates as well as the new one. In some domains, more than 4, 5, more than 10 years in parallel stream, because you have old system running, and you must implement new system in the field, and the PKI must then support both. So inventory, and then thinking about modification and thinking about running parallel mode, the old and the new economy system.
Let's just state, last December, 18 European states signed a joint statement on, let me get this right, a composite approach. Not a hybrid, but a composite approach. What's the technical challenge for this?
First of all, Jörn mentioned this, if you have knowledge of 20 years elliptic curve and RSA, 1K, 2K, 4K, and so on, and you heard about a new standard comes down the road, you heard about new risk comes down the road, but you have no learning curve, it makes sense that public authorities think we combined existing secure system with some elements of the new world. And this kind of creation, a European harmonized way, was this first letter in December last year that 18 member states in Europe have signed up, included Germany, included BSI president, that they will follow this model, and it's completely understood from the industry point of view to be on the safe side. From the implementation side, as explained before, if you have hardware which support both technologies in, for example, designs and accelerator, you need more chip, you need more computer power because you must create this for both. And at the end, if this algorithm in combination comes to the real life, we must also think about performance because calculation needs then more time. Yeah? And we have a lot of real existing implementation where citizen knows how long waiting time you must looking for. I give you two examples. Payment, if you go to the points of sales, 300 millisecond is today the transaction check. Yeah? If you go to the border control, passport, reading time, 3 seconds. If you have this kind of modification of algorithm, needs more time, could be happen that you need some double time for border control and double time for payment. And this kind of brownfield is for us one of the big challenge to bring this hybrid or combination of old new algorithm down the road.
Jörn, how important is the research on post-quantum cryptography at Castell, at KIT, when the algorithms are mostly recommended by NSIT?
It's true that NSIT is leading this standardization process, but it is an open process and everybody can contribute. And so an employee of mine, a colleague, did indeed eliminate one of the candidates. So we had actual impact on this in a negative way. We did eliminate a candidate, but he did also a very, very thorough quantitative analysis of the time you would need for a quantum computer to break Kyber, one of the candidates. And Kyber looks good in his analysis, and this is kind of a support for standardization of Kyber, which also happened. But many researchers worldwide are contributing to this process by showing weaknesses, eliminating candidates, and maybe supporting claims.
So it's very much a case of optimizing the algorithms for specific use cases?
No, we don't change the algorithm. We improve the analysis. So maybe the algorithms of the attacker. So that's indeed what people do, that they look on how could certain attacks work, what are the best known attacks, could we improve on those attacks, and if attacks are so much improved that security doesn't hold anymore, then the candidate's gone.
Finally, I'm sorry to keep picking on you, Detlef, but technical migration to post-quantum cryptography looks and addresses at many markets. What are the key parameters for PQC algorithm selection from an industry point of view? And can you name some examples? And then I'll also ask basically the same kind of question for use examples from both Thomas and Oliver.
First point is we would expect that 95% or more are brownfield migration. That means we have existing ecosystem, you have existing application, and that must be migrated. You have less than 5% new application. Maybe Galileo, satellite, ground communication could be one. 6G could be a new one. So we have this relation. Number one. Number two, if we have the technical standards, we need at the next point the application standards. For example, for banking, we have EMVCO. They must migrate this in their standardization. ICAO must bring this in travel documents. So we have different organization and different responsibilities to bring technical standards into application standards, into protocols. Yeah? And this is for us one of the boundary conditions, and from the existing real field application, we see at this moment different topics which are relevant. One was mentioned before, performance, how long we need for this kind of encryption, decryption, because we have some existing real system in place. Second is the increasing of security and agility for the next 5 to 10 years. Yeah, this is for us this is the second important point. The third is we have today limited resources on microelectronic chips. That means the computer power is not big, it's very small. Yeah, the chip, for example, in a passport is 4 square millimeter today, worldwide. So we have not a big chip to have big computer, to have big memory. This is number 3. And number 4, we have many applications in mobile devices where you have a simple battery. And for encryption and decryption, you need energy. That means energy efficiency. Encryption, decryption is important, for example, in smartphones. It's important in smart cars, which are used batteries, because any energy you need for such kind of decryption and encryption reduce the lifetime of your smartphone or the distance of your car. Yeah? So you need also this kinds of efficiency from the point of view. And as explained, more than 95% we have existing system, existing running system, and now we must implement this new technical topic into this framework in different domains.
Would anybody else like to comment on that in terms of looking at this from an industry point of view?
Yeah, for us, upgrading to PQC is much more than changing some ECC algorithms by hardened PQC ECC algorithms. So one of the biggest challenges might be what you called before brownfield. In our case, our customers have deployed millions of licenses, millions of CodeMatter dongles in the field, and they have a security controller which is several years old, which might be not upgradable to PQC. That's one issue. So the first step is hardening the license deployment process so that this is using PQC schemes while still using in a compatible way for the next 5-10 years the old existing CodeMatter dongles in the field. Also, that's a requirement from the customers that have applications in the field that need to continue to operate. In parallel, then our new hardware, our new CodeMatter dongles and the complete ecosystem with License Central, with CMX licenses, with cloud-based licenses will be upgraded to PQC. So not only the license deployment, but also the license storage will then use PQC, so to reach a real higher level of security. But here we have the performance issue, of course, but probably the new, and we work intensively with Infineon and using their new already certified crypto controller series that can do that has some PQC acceleration. So the performance issue might be dealable, but on the other side, the keys are much larger. So if we talk today about a 256-bit ECC key This will expand to 2 times 2 kilobit of kilobit of keys for PQC algorithms. So that's much, much more. And in our solution, we need to be able to store multiple keys for multiple different licenses, multiple different products for one software vendor or device manufacturer. So we need clever combinations of having a PQC key per firm item, per company, if you want to say like this, and not using a PQC key for each product item. So that it's that's really handleable in practice. So on a PC and in the cloud, you have enough memory and you have enough resources to do it differently. But if you have also a piece of secure hardware, you need to take care about this memory restrictions and so on. And of course, we want to have one system. We don't want to have an incompatibility with the licenses stored in the cloud, stored in an activation-based, and stored in a secure hardware device. So lots of challenges in implementation above only changing an algorithm.
Detlef?
Maybe to add 2 topics. Number one, from industry point of view, it's very important that we have in the PQC library future one European library and not national specific frameworks that we have today. So if you go BSI TR2102, it's a German library. If you go to INSSI in France, you have a French library. And at the end, we would like to implement one mainstream into hardware, one mainstream into the library on the hardware, and go into one certification. So this is a positive thing. The negative thing is we have learned that this first publication from DG Connect of the European Commission, it's a high-level document created by ENISA plus member states, and this is step 1. They will create a step 2 publication second half of next year, which are created from the member states level. And this gives me the impression that's not the harmonized view, it's coming more from, from top down, goes to bottom up, and then we have national specific definition of risk, of priorities, and this is for me the negative point of view, which we must also keep in mind that we have some different speed in Europe.
Jörn, let me ask you this. How does your research help Infineon address technical challenges of this transition from a classical cryptographic method to these more composite approaches?
I think we have currently no direct collaboration, but what we actually do is we think a lot about digital sovereignty, and so we are currently building a cyber vault where we try to make the security explainable, such that you can explain the architecture and you can convince someone that your data is secure in there. And of course, we would like to maybe build on Infineon chips. I think some are in there, but we bought them the regular way. They were just incorporated in the products. And so we actually built on their research and on their knowledge to build a system where we want to later convince the legal people that it's GDPR compliant to execute algorithms on medical data, on sensitive data in this cyber vault.
Okay. And can I ask here, is anybody here from the company, do you know if any of your companies have actually started any cryptographic inventories or anything? Has anybody started at all? No? Anybody like to comment on the fact nobody's actually started anything yet?
Maybe it's not visible, but the BSI organized at this time every 6 months a brain pool meeting and invite some large companies. And the last meeting was some weeks ago in Frankfurt at the German railway. The next will be in November in Berlin at the Bundesdruckerei. And in this roundtable, this Ministry of Interior participate, BSI is participating, and some large companies are participating to exchange the view of some big German companies, what they are doing for their own purposes, and to bring also the view what's of interest for the German federal government, for German projects and institutions. And this kind of exchanging is running, but it's not visible, and you see not many publication on this.
Are they normally well attended? I mean, or are they growing in attendance for these kind of meetings?
It's growing. We have now some more companies in this round, but it's a kind of closed events, you can say. It's not an open event where you have journalists and we have many.
No, I mean in terms of corporations that are now being included and taking this seriously, yeah?
So the main aspect is to have this kind of informal platform between industry and government to have a look from both sides, what are the next milestones from the industry point of view and what are the next milestones from the public authority. And for us, the European regulation and also the national regulation are a must. We cannot ignore this. And I hope that most of these regulations fit then with the requirement from the industry like WIBU, that we can take exactly the products that we develop for these markets can be reused also in the private sector.
Okay. Now, Thomas, I know you think I haven't actually noticed you there, but I have. I've been saving this up for you. Can you very briefly summarize what the SAP entitlement solution is about and how it works with the WIBU code meter?
Yeah, sure. I think when you have followed the session just before from Roche or from Mr. Rusiek, you already have an idea what is EMS about. And this is exactly what Roche is very nicely doing. It's about the integration of the complete chain from ordering until really the security you find with EBU. So SAP is a company who would like to give you the business suite. So that means the complete integration of all your business processes. And because our customers are going more and more from the physical world to the digital world, it means not the physical product is anymore in the center of your, I would say, of your thoughts, but more and more the products from the digital world. Entitlement management becomes more and more important. And the core element of entitlement management is the entitlement. What is an entitlement? It is a right. And entitlement means it is a right you give someone, and we take the term of an entitlement very broad. It's not only a license. Even a license is a very, very important type of entitlement, but it could be any kind of other rights, especially in the digital world. An example could be the right for service of maintenance, the right for warranty, the right to get access to a learning portal, the right to get, even the right to get access to your parking garage is a right, is an entitlement. And companies who are dealing more and more with rights, they need a repository to handle all these rights very centrally, to see what rights have I given to a certain customer and what are the exact nature of this right. And I would like to automate on this right. I really would like not manually do something. It has to flow completely automated from order entry until securing and executing on the right. And this is entitlement management about, and therefore, of course, we need WIBU because all the security aspects, this last mile, we call it, can only done by WIBU from our point of view.
Sure.
And we have heard some years ago that the title digital twin. At this time, this was only a figure, but now we have some standardization, what that means concrete. Number one, with the digital twin, we will see the digital identity, not for people, but also for products and for machines. And some new words come down the road, like digital product passport, by the way, by European regulation. And this type of digital world must be also implemented in the IT system like SAP, in the shop floor as well as in the office world. So both areas must deal in the future, not for people on identity, but also for objects, for software, and at the end, because each of these needs identities.
It's, Thomas, the combination of SAP's entitlement solution with WIBU's code meter, why do you think that creates such significant value for the consumer, for the customer?
It's exactly because of this end-to-end flow.
Right.
You want to automate this, and you want to make sure that the content of your economical contract you have with your customer, that means what are you promising to your customer, finds its way completely through the complete chain until you really have a license which is secure, and which means also that your customer is not overusing it. And because SAP is not providing this last mile, we call it, therefore we have this very close relationship to WIBU. And entitlement management, AMS it's called in our world, is a kind of the orchestrator of these rights. Yeah, we distribute the rights to WIBU if it's a license, but also to a kind of cloud tenant if you have a right for a cloud tenant, or we distribute it to any kind of system. My example is a parking garage. Maybe a parking garage needs to know you have the right to enter. Yeah? And this spider in the web, to say that, is AMS.
Oliver, security of software licensing is often considered, not by me, but by others, less important than flexible licensing. Now, why does post-quantum cryptography play a role in software protection?
Yeah, it's a little bit similar to what I said before. If you have, if somebody else is able to generate licenses, then all the efforts make no sense. Yeah, we often hear that software vendors, device manufacturers start to think about licensing because they want to implement new business models. They want to sell additional to perpetual license, so that means a one-time sale. They want to use the new business models like subscriptions, like pay-per-use. They want to have it very modular so that they can offer a product in a basic, with some basic functionality to a very competitive price to the market, and then add features on demand depending on the user's requirements, and licensing these additional features in a different way. That's the main driver, and showing the return on invest for the device manufacturer, for the software vendor quite fast, why they start thinking about using such a licensing system. And we had that discussion often that the device manufacturers, software vendors, they think they know their customers and their customers are okay, so they don't think that the customers will actively bypass the licensing they provide to them. But as soon as then pirate products are available in China, for example, and that in a way maybe that the original product doesn't need to be changed because they have been able to create a license or to modify it a little bit, modify the application a little bit, and then it's working, and then the customers can use it without paying it, or maybe they buy only a few licenses, but they are using much, much more. As soon as that happens, and some of our famous customers, I will not mention some names yet, now, also in the automotive area, they have seen that extremely in China, and not just a simple thing. The Chinese organized crime, or I don't know how you want to call it, they have spent a lot of effort to make the copy product, the pirated product, looking exactly the same like the original. So even they try to copy electronic devices from our customers, and they copied, they bought our original dongles and modified the case so that it looks exactly the same. So you see that latest at this point, when this happens, security becomes very important, and then a lot of efforts are done to increase the security level. And on the future, I fear as soon as this standard, and we use asymmetric cryptography for the license transfer, for the license creation, as soon as this can be broken by these criminals, then it's more or less worthless. So we need to be able to have this hardened way of creation and deployment of licenses prior to the technical possibility to bypass the existing schemes.
I know Detlef wants to say a few words.
Maybe, Oliver, we can expand a little bit the view. For me, software today is not only simple software for for example, machines. We have also the combination of software plus artificial intelligence in the software. And more AI goes into edge, into healthcare, into consumer electronics, automotive, smartphone. Each smartphone have today 10 algorithms. Not everybody knows this. Yeah? So they have this in the edge. And these AI get every quarter some updates about performance, about quality, and so on. And with this, you have a kind of speed up, not only on traditional software, but also on software which have AI function and must move into the edge. And for me, this is a kind of driver to bring more software updates into the field for connected devices. Yeah.
Yeah, that's completely right. And licensing is only one issue. The other issue is that through the protection schemes for data, AI models, and program code that protect not only to enable different licenses, but also protect the integrity of the application, the integrity of the code, and makes it more hard to do reverse engineering because it's protected. So that is additional factors that require a high level of security. And in fact, we have today applications that protect the AI application and the AI models. For example, in medical equipment, today these AI models that help the doctor to analyze, for example, the results from computer radiography equipment and helps them to see faster the critical points. These AI models need to be frozen with the certification of the medical device according to MDR. And we can help to do this integrity protection for the models as well. We work on monetizing AI models. There are a lot of, there's an ecosystem coming from NVIDIA for that purpose as well, where we work on providing the secure licensing for this purpose. That's one. And it can be extended, maybe we come later to that point, to other kind of licensing of data, for example, for additive manufacturing, for 3D printing data.
Can I ask, Oliver, in terms of CodeMeter, what are the actual technical hurdles for introducing post-quantum cryptography?
Yeah, there are several. So it needs to be implemented in all types of our license containers. So in the secure, in the CodeMeter dongle with the security controller coming from Infineon. It needs to be implemented for the CM Act, for the activation-based, software-based licensing scheme. It needs to be implemented in the CM Cloud server. So, and that's only the site where the license containers are stored. It needs to be also integrated in the whole ecosystem. So creating the licenses, deploying the licenses in License Central and with the other tools, everything needs to be upgraded to PQC with the difficulty of the larger key lengths, and what is very important, with the difficulty of create an upgrade path for our customers that are existing users of our systems today, from the today's solution to the future solution, without replacing everything in the field, which would be not possible.
Are there any other hardware constraints? I mean, we talk a lot about the software, but in terms of the hardware that actually goes.
Yeah, in terms of the hardware, there will be a new hardware probably in 2027 with that new security controllers that have special accelerators for the PQC algorithms. But the today's hardware that is in the field will be used for the next 10 years as well. So we need to improve the security level for license deployment, license updating, also for this existing hardware. That's very important for the customer base.
Let me throw this over to the panel. How does SAP and WIBU's solution align with PQC migration strategies that's already been discussed by both Detlev and Jörn? And what are the opportunities for collaboration? And who wants to go first on that?
Me?
Yep, Thomas, off you go. Yeah.
Maybe I didn't find out if you want.
Let me say it again. How do SAP and WIBU solutions align with the post-quantum cryptography migration strategies already discussed by Infineon and KIT that we've heard here today? And what are the opportunities for collaboration in that?
Okay, no, sorry. I think, well, I coming from the business point angle. So from our end, we somehow hand over this problem to WIBU because I said, yeah, you have a contract and you would like to fulfill on this contract, yeah, and now of course you would like to make it sure for your client, for your customer. That means you need to have a secure software, and whatever challenge is coming, exactly this is the reason why we say there's WIBU, and now we tell our customers it's more and more important that you somehow that is this close technical relationship between these two systems and this business relationship between us and WIBU. And now we just direct our clients to WIBU in these kind of critical questions.
Yeah, I think that's true. What we need to upgrade as well is the authentication of the SAP ERP system to the license central, so that not somebody else can create that license. Only the EMS is able to send the order to create the license. Everything else, how the license is created, what technology is used behind that, and what technology is used to protect the software or data, then is outside of the ERP system and outside of the business process.
Exactly. Of course, in our technical relationship, we have to be state of the art, and whatever is needed, we'll have to do. And yeah, this is something. This kind of concern is. I think we have a specific security department in SAP with a lot of experts who are doing this. We call it a product standard. So I'm not part of this department. So if there is if the next level, then they will tell me, hey, Thomas, you have to keep the product standards. We are the biggest software company in Europe, so you can be sure that these kind of problems definitely are on the radar of my colleagues. Yeah, and with the help of my colleagues, my department will take care that everything is also in the future safe. Yeah.
Okay,
you were talking about migration, and this migration might not be a one-step migration. It might be a more continuous process. To give you an example, you can even harden non-quantum safe key exchange protocols by over-encrypting the communication with a symmetric key. So if you have a symmetric key from the past, from a previous use, you can just use it to do encrypted key exchange. And encrypted key exchange is already a huge hurdle for someone having a quantum computer, because this attacker doesn't even have the data to attack because it's encrypted. And this is just one tiny step, and then one has to go step by step until we fully replace the non-quantum safe crypto.
Okay. I know Detlev, you wanted to say a few words on this?
Maybe we have not talked on one dimension which is a little bit important. We are talking on crypto agility, but we are talking also on products which have different lifetime. So agility for a product which has 3 years lifetime, it's less flexible if you are looking for products which have 20 years and more in the field. That means you need at the end different strategies. Other terms, one fits all doesn't work. So we must also think about industry application. We must think about automotive application. We must think about consumer electronic application, which have different lifetime. And then you must bring different agility of hardware, of hardware, software co-design down the road. That's at the end the point. So one fits all is not the game.
Yeah, I can only emphasize this. We have a joint project with WIBU-SYSTEMS where we think about crypto agility in medical devices, and there we have also several steps, and one is even to be able to replace the hardware, to kind of pull out the dongle and replace it with a new one capable of handling all the more advanced post-quantum things. But it has, so to speak, a software-based migration up to a certain point, and beyond that, because medical devices are usually used for a long time, we even take into account that pieces of hardware have to be replaced, and then you need this authentication process that you really know that it's not the attacker replacing the hardware.
Okay. Anybody else want to comment on that? No? I mean, this crypto agility, is I understand what you're saying there, Detlo, that there's no one approach fits all. You have different products with different, life cycles over them. But how would a small or medium company be able to adopt these solutions cost effectively? I'm not just pointing that out to you. I'm also talking to Thomas and to Oliver here. I mean, it's quite a thing. I mean, is there some kind of plan or roadmap, or is there some process? I mean, how do you plan for something like this over a product? Your products could be consumer, they could be governmental. You could be talking about an 18-month timeline. You could be talking about a 10-year timeline. Sometimes it seems very, very devious the way you have to try and plan for this.
Well, I can only speak now for EMS. We are a cloud solution. So our price model is based on the number of entitlements, which do not change. If you're a small company and you might have just a small number of entitlements, and the price is pretty cheap. Yeah? And if you're a big company, then it's getting higher the price, but you have deeper pockets. So that's the idea of our price model. And because our software, EMS, running in the cloud is always the latest version, always the latest security, always whatever comes, we have implemented as SAP. So our customer who's consuming EMS as a cloud service, they can be sure they are on the top edge security methods which are available on the market. Yeah.
Okay.
I think in our case, it's not so difficult for the customer. So it's more or less our task to provide the tools and to provide the new dongles that then can handle the PQC algorithms, as well as the cloud server will be able to do that from the beginning, the software-based licenses as well. And in our business model with our customers, with the software vendors or device manufacturers, we either count the number of licenses that are issued, that's one option, or we have a small percentage, something like 0.5% or something like that, of the value of the products that are licensed with our technology as a flat rate, and without counting the number of licenses issued. And then it will make no difference if the vendor is creating a new license in a compatible way for the existing dongles, for example, in the field, or if he is creating a new license with PQC schemes.
Maybe I can add two topics, Steve. Number one, we have some change in policies. For example, in industrial IoT, we have seen the change from the perimeter protection 5 years ago. Now we are talking only on zero trust. That means you need credentials before you start machine-to-machine communication. Credentials must be stored secure. So you have some kind of new framework, goes into the shop floor, goes in the operation OT, and not more this traditional old perimeter protection part of you. Number two, and this is very important, we have heard today about the Cyber Resilience Act. Some products are not able to create software updates over 5 years, but 5 years is a must in this regulation. I have heard some washing machines are not able to do this. You buy a washing machine, you have a warranty of 1 year today. The Commission say no, in the future 5 years. So these examples show you that also there are some migration in many markets to fulfill a Cyber Resilience Act, which comes down the road in 2 years from now, to modify that software update in the future. It's a must. Secure access is a must by the European Commission. And for critical infrastructure, you need the third-party certification by, for example, TÜV. That means you are not, the market is not more open to think about you can buy what you want. In the past, the CE label was on safety aspects. Now the second coin come on the table, the second side of the coin, security, it's in the future the must. Otherwise, you must leave the European market. So this change needs also some modification to bring also the thinking of PQC or algorithm agility into future products. That's a kind of cleaning product portfolio. The Commission is aware that some products will be move out of the market and some companies will move out of the market. But this is a kind of clearing situation what the commissioners have in mind to bring this step up on more security. But this is a one way. We cannot think about some years later they will stop this program. This is now starting.
Let's stick with this area of Europe and its impact upon some of the companies out here. But yeah, let me ask you this. What measures should the European Union take to avoid falling behind in this, I'm going to call it a quantum race? And do you already know of any measures that you can share with us?
I think the European Union is not so bad in the quantum race. We have very terrific researchers, very successful researchers. I think the main problem, but they know, is that a lot of the ideas do not fully go from academia to the market. And my fears are a lot higher that we will miss another market, not the quantum market, but the AI market, which is also going to be huge in future. And it could be that there we will have some, the winner takes it all development, that the big companies who invest billions in models which are hosted in huge gigafactories, which are next to some power plants, that we will not be able to catch up with it. I think energy is very expensive here, and energy is one of the main ingredients of these AI models. And so I fear that we have to really think about what to do there. And I even heard the idea that it would be a good idea to think about having compute centers outside of Europe where energy is very cheap, and then think about IT security solutions to still have sovereignty even though it's not located in Germany. And I think we should think about kind of explainable, convincing IT security, because we should not think about digital sovereignty as everything must be built by our friends in Germany, but there must be some way to convince us that they're not harming us, that they are leaving our compute center alone, that they're not doing any espionage on us. And then I think there will be much more collaboration, and then we will be able to maybe catch on the race with an enlarged vision of what digital sovereignty means. It does not mean we have to do it ourselves. It means we understand what other people are doing. We understand it so deeply, and they can explain it so well that we can use it without harm.
What kind of time frame would you say?
I think this idea of building compute centers outside of Germany, which are still trusted, this could be something which we could do quite soon. I would propose that we build like racks and computers together with security measures in containers, and then seal the containers in a very secure way, and then just move them to build a modular AI supercomputer built from trusted containers.
Okay. Let's stay with this idea of timing. Oh, sorry, Detlef, I know you wanted to say something.
Maybe from the historical point of view, it's important to see that Ursula von der Leyen have stated in 2021, any devices which can be connected can be hacked. This was the initial point to create the Cyber Resilience Act. 2022, we got this Russian-Ukraine war. Since this time, Ministry of Interior and Ministry of Defense are talking on hybrid threat, not more cybersecurity, hybrid threat. That means you have multiple attack situation in Europe, not only from the civil, not only from the criminal area, but also from some public authority area. And they have money, they have budget, and they have a little bit power. And that means, from my point of view, we have a new game. It's a kind of game changing since 2022, and we are not talking on traditional hackers or traditional black hats or traditional situation. We are thinking about some government agency or related to government create some attacks, and this can go to critical infrastructure, to important infrastructure, to all these topics. And for me, this is a kind of new game changing in this area, and we must think this also in the box that this is now on the priority behind the digital sovereignty.
I completely agree. I think that before the Ukraine war, we thought a lot about espionage, and now we are thinking more and more about kill switches. We fear that kill switches might turn everything off. And I think we were too relaxed in the past and felt too sure, and we didn't see this coming early enough, and so we have to take care now.
I know that there has been more focus upon timing, and I'm going to use this to segue into a question for Detlev to talk about I have to read this out, coordinated implementation roadmap for the transition to post-quantum cryptography from the NIS group. And I know that they've put out a certain amount of timings and stuff for this as well.
Yeah, there was 2 deadline defined. This was published 2 weeks ago. They say high risk must be 2030. That means high risk for public sector as well as for the private sector. United States defined only public procurement in the United States for 2030 for high risk. And for medium risk in Europe, the deadline is 2035, United States as well, and in UK as well. So they have their very synchronized framework about risk approach, about implementation deadline. This was mentioned before that this was published now. This was expected, by the way, in April, but there was a lot of overwork of this document and modification, and we have heard some friction, let me say, between the responsibility of different agencies on the European level, like ENISA, like DG Connect, and so on. Now the policy could be changed that now the national bodies create the next level of paper which goes more deeper. And say, for example, in Germany we have toll collect. This is a PKI system. It's only in Germany working. Is this a critical infrastructure? Is this deadline 2030 or what kind of? Such kind of national priorities comes down the road to say we need also in trucks and in buses onboard units in 2 years or 3 years, which we must have PQCs, and you must replace all the existing equipment. Such kind of national-driven programs comes next year with the next, let me say, publication, and then we see more concrete which domain and which risk approach is mentioned by member states and what is the concrete deadline. Today we have more this umbrella view, big picture you can say, but for this, from my point of view, this next level of documentation make it more concrete.
And I think there are even more deadlines. So for PQC, the 2030 and 2035, that's well defined now. But if you are looking on CIA, on the Cyber Resilience Act with the deadline end of 2027, that doesn't require that the products have post-quantum crypto inside, but it requires that the products fulfill many requirements that are on the way to that allow this updatability and so on. So for products, for device manufacturers, for software vendors, there are a lot of tasks to do in the next 2 years, or to have finished in the next 2 years. It needs to be done maybe earlier, finished earlier so that it can be certified and everything.
Maybe we can make it also a little bit more concrete. In the Cyber Resilience Act, we have understood that this year, most of the companies must look on their own product portfolio and the risk of existing sold products in the market, and must think which of them must be uplifted to get the CE label tomorrow, which cannot be uplifted, must be finished, and which can go straight ahead. This must be decided this year. Next year, all the important implementation in the companies are important for the purchase department, for the development department, for the quality department, for the sales and after sales department. You need a lot of changing. This must be implemented next year, 2026. In 2027, you need the CE approval process. The deadline is a deadline, but you need the product before the deadline on stock.
It certainly does seem, especially after some of the presentations that we've had today, that they're, you know, we're talking about quantum computing, we're talking about it coming, we're talking about it, but also real-world external factors are now starting to really cause some kind of, you know, increased attention and focus to try and get this moving as quickly as possible. Let's just switch back to, you know, products for a moment. Can I ask Thomas, what's SAP's strategy for entitlement management in the future?
So in general, of course, our strategy is in line with the overall company strategy. So let me just take a step into our board's shoes, and then what is the SAP board setting as a kind of strategy, which we as a part of the product portfolio, of course, will follow. And I think there are two main topics, I would say. One topic I already mentioned today, and this topic is that we are best of suite. Yeah, we think we win the market not by being very good in a specific field, but we win the market and we will give the most value to our customer, that we will give an integrated suite of products, which is really perfectly integrated, though that's the main hurdle you also heard from Roche, which is integration goes down. So this is one topic. And the other topic is clearly AI. It's really, SAP will move into AI, and we do a lot of things, and every day. Yeah, the AI is really on our top of our priorities. And why is it on the top of our priorities? Because the role of a business user will change completely. It will change completely. And we do not see it today, but we will see it very soon. It means that you are not doing transactions anymore, but you are somehow the manager of agentic AI. So it's all these agents which we currently see in the scientific world, or sometimes say these agents will become real, and you as a user will only do the exceptional process, and you will managing this agent, or you will be the one who's implementing them, who will doing the decisions. You're moving as a user into the role of a decision maker, or you don't have a job. That's a future of cloud ERP, and this is a strategy coming from the board, and we are following. Going down now to EMS, what does it mean? Well, we are not a user-centric application. Our application runs in the back end, and ideally, nobody cares because everything is running fine. So we are already there somehow, and we will support this by enabling our users with some AI tools even to be more productive when configuring our solution, and giving data to other solutions that they can build, say, agentic AI, say agents, because you need a lot of data. But some of this data is within entitlement management. Mm-hmm. Combining that with other data, that gives you the database for to build the AIs.
Yeah. Steve, to explain that the topic of AI is much, much, much more complex than PQC or quantum computing, because we are talking for different bridges between cybersecurity and AI. You can define three classes: cybersecurity for AI, this was mentioned also by Oliver. Second is cybersecurity with AI, it's a complete different topic. And cybersecurity against AI, because the attacker uses also AI. So these are the three different domains, and there are a lot of research topics in this area. Number one. Number two, we are not talking on this AI, we are talking on conventional AI, we are talking on anomaly AI, it's completely different. We are talking on large language, small language AI, and now agentic AI. These are different boxes with different algorithms, with different application behind. That show you a little bit that the AI topic is a little bit complexer, and also sometimes a driver for new business, but also a driver for software update topics, and a driver to bring more security into the IT system, not in the network only, but also in the edge. We call this endpoint security. Both network security and endpoint security must be solved on this topic.
Mm-hmm. I'm going to ask now, with everything that we've heard, why will code meter dongles still be needed in the future alongside software and cloud-based licensing procedures?
It always depends on the application and on the threat scenario, which kind of container is best suited for the application. But we see many applications that need to run with a high level of security in an offline scenario. And even that, for example, engineering tools used in the office area might often use cloud licensing. They don't need a dongle connected to the PC workstation at the engineer working with the engineering tool. But if we have a PLC in a process automation system that cannot be securely switched off. It needs to go shut down the process in process automation with exactly defined steps to be able to shut that down in a safe way. So in that case, licensing needs to be local, cannot be used from the cloud probably. On the other side, offline scenarios are existing in other schemes as well, and having a small piece of hardware is something which, with limited complexity, evaluated and certified according to common criteria, in regard of the crypto algorithms, that is something that might be not possible at all, even on a PC, because the complexity is such big that an evaluation is no more possible. So a small piece of trust anchor is in many applications very valuable.
I think there's one trend expected in 1-2 years in Europe. We are talking on so-called the business wallet. The Commission have published the specification on a business wallet. It means for people who are working in a company will get a wallet on the smartphone. You will see also the driving license on the smartphone. You will see in the future passport, travel credential on passport, on smartphone. And this business wallet is used to bring also digital identities for the operator into the factories and also for the people in the office domain. And it's a kind of digital transformation. And the combination of the dongle access right with this business wallet, which is an app on smartphone, could be a new game changer to bring also the digital identity of software, of objects, and on people together. And this was exactly mentioned by the SAP digital twin. We are now get more concrete understanding what that means. The past, this was a buzzword, you can say. It was each person have different interpretation, but it was not clear what it means. Yeah? By the way, this business wallet will be tested by a large-scale group with more than 100 participants starting in September. It's funded by the European Commission under the IDAS 2.0 regulation. And they will bring out this in a kind of real implementation to show up how this can really implemented in business models in industries. Yeah. And for me, this is also a kind of game changer. Create new business models. And from my point of view, this is a window of opportunity to bring also this kind of authentication, identification into the market. And this is, from my point of view, the dongle is one piece in this picture.
If you don't mind, I'd just like to circle back to this the subject of AI, and especially with SAP and entitled management. What is your SAP strategy for dealing with AI, especially with entitlement management?
I think I outlined already a bit the overall idea behind, and with EMS especially, there are two dimensions. One thing is that our customers, the customers of EMS, of course, they would like to offer AI-based services more and more. And for us, it's it's an entitlement. Yeah, you are entitled to use an AI. You are entitled to different kind of coins, to tokens, whatever. And this is, I would say, a use case for EMS, but it's not something completely different. It's one use case beyond a lot of other use cases, but it simply shows to our customers that EMS for digital products become more and more important because AI becomes more important. What is interesting for us is software. We are a software product, of course, and as I already said, we would like to add AI capabilities to our users, which especially would mean we have rule generation capabilities, we have scripting capabilities, and these things are currently traditionally. You have to do the scripting by hand in the future, and this is we already have a working prototype. You just put in natural language, and our AI agent will automatically translate this into the right script, and this script is then the basis for a rule in entitlement management. This is during design time, during you design an entitlement model, and with AI capability, you are faster. That's it.
I'm going to pass this over to WIBU here. What is monetization of AI models and 3D printing data all about?
Yeah, that's similar to monetization of software realized function in devices or in software. On AI models, you want to measure the usage of the AI model, so that's a kind of monetization that can be realized with the same mechanisms, with the same principles. And the additive manufacturing area or 3D models, that's in fact very similar, but a totally different use case. So, for example, Daimler Trucks is doing the spare part logistics in 3D printing. That means in the past you have produced in the automotive industry a lot, you have produced spare parts, you have put it on stock for 20 years, then you wasted what's remaining. And if you need a spare part within this 20 years, you send it by air freight to any location in the world so that the repair station can put it into the car or truck or bus. And that is not a very good sample for sustainability and for the environment. If you are able to produce the spare part by 3D printing at the place where you need it, then of course it's much, much better. But a spare part business is a very a business with a good margin, and no manufacturer wants to give away this his spare part business. So the protection of the 3D models is very important, and then as well the protection until to the printer that produces the part needs to be controlled in the volume, how many parts are controlled. And that is, from the licensing point of view, it's quite similar like pay-per-use models with software. So it's pay-per-use models for the digital rights for using and handling this production data for additive manufacturing.
Okay. I'd like to just throw out a couple of questions to the panel as a whole now, just as we move into the final stretch. Can Europe achieve digital sovereignty without relying on non-European tech, or is a global collaboration essential? Immediately goes to Detlef. Go on.
Yeah, I think from the European point of view, we are telling the story. European must be open, number one. Number two, we have a lot of regulation in Europe. GDPR, for example, Cybersecurity Act, Cyber Resilience Act, AI Act, and so on. Such kind of numbers of regulation are not existing, for example, in the United States. Yeah? They can have their business models, they create different ecosystems. You have the Android world, you have the iOS world, you have the Windows world. Yeah? And each of these companies have no standardized solution. They create their own framework, and at the end, high proprietary security architecture in hardware and software and everything. So this is, for me, a complete different policy. In China, they use, from my point of view, cybersecurity as a kind of closing the door for non-Chinese companies. Yeah? And say, we have local certification, you are not a Chinese company, you cannot get the stamp, so you have no access, for example. So China take security and cybersecurity as a kind of door closer. Yeah, United States completely different, and Europe is the open market a little bit. Now we are talking since some years about sovereignty because we have learned that some products are not developed in Europe, are not produced in Europe, and we cannot control if there is any kind of backdoor solution inside or any function which I don't know, but I have it in my part in the terms of the military. They are talking something on sleeping person. Maybe you have also sleeping electronics in some devices, areas. So that's my point of view, to think Europe is now thinking about more what are the key technologies which we must have under control in Europe or must develop in Europe and can analyze in Europe, and what is not so important. Yeah, and this kind of make it more concrete, digital sovereignty, and not take the buzzword. Yeah, it's very, very important to bring it more down the road. What this means for products, for systems, for infrastructure, for communication, and at the end for chips.
So, how do we balance in Europe? How do we balance innovation with regulation? I mean, how is this? How are we able to do it? We seem to be in Europe the most regulated area, as you said, things through GDPR, etc. So how do we balance that if we're supposed to be in this quantum race? Any ideas? Any
I would expect that sooner or later we have not only the European roadmap, which is a kind of deadline for some risk views. I would expect sooner or later we have this also as a European regulation, to have a clear implementation plan for clear application areas. And from my point of view, they will start with the public domain, public sector, and then goes to the critical infrastructure, then to the essential infrastructure, and goes and step down. But sooner or later, I would expect we have also a migration, PQC, regulation on the table. The roadmap is a kind of front runner. It's a kind of make the industry aware, make government aware about what's going on, to bring all on the same page. But later on, you need a clear regulation topic about real deadlines and penalties. Yeah.
Yeah.
I think balancing regulation and innovation is very, very hard. It might be easier for post-quantum crypto, because there we kind of know what we want. We want this transition to happen. But if we think back at AI, I fear that we will regulate everything, and then the models produced in the US will be better. And then we will use them. Mm-hmm. It's the same with our secret services. We're not allowed to do this and that, and then we get a hint from a befriended secret service who got this by ignoring all the rules we give ourselves, and we use it. And
you think we kind of push ourselves into a corner?
So I fear we do it right now, and I think we should really very consciously do so if we do so, or choose maybe not to.
Okay.
In my point of view, we cannot do everything ourselves in Europe. So we should continue the cooperation in research. We should continue the cooperation in business for sure, because we want to make business. So we need to work with the US, we need to work with the Asian countries, with China. And what politicians might do as the best is to try to get international standards. And then we can follow the international standards, and we should have the competence and the people to do the implementations according to the international standards by ourselves, so that we at least have at this point our own competence and sovereignty here.
Just to bring it back to individual companies, as it were, how should a small business prioritize its PQC investments? How do they go about prioritizing for this now? You know, we're talking of different timelines, we're talking what's immediate, what's midterm, but for a normal small business or a mid-sized business, how do they prioritize?
So I start from the value chain in the first step, from the microelectronic point of view, from the discrete secure element, from the embedded security point of view. We must bring this in our roadmap. We must bring this in different products and different platforms and different applications. And we must offer this in different markets. We cannot ignore this. Yeah? We know that many customers, for example, in automotive, are concrete, asking us about, because they are thinking about generation of cars, yeah, and they must think about next generation, also next afterwards, to bring such kind of elements in the field. We have a lot of such kind of discussion. Industry as well. Automation machine producers are talking now at which time we are able to sell such kind of chips. For computer, we are talking with some companies. So the request is more and more concrete, and we must bring this down the road as mandatory. It's a feature which is needed in the market. Otherwise, we are jumping out of the game.
Maybe the small companies don't need to focus so much on PQC today. So the first thing, if they have products that are somehow networked with electronics, they need to focus on CRA, on Cyber Resilience Act, which is coming, which is very close. And regarding PQC, if they are using licensing with CodeMatter, we are happy to help them in the journey to upgrade to PQC-ready licensing solutions that gives a higher level of security for their products as well.
Is there a great cost in if a company actually has a legacy system? Is there a great cost migrating up to PQC compliance for a legacy system? Yeah.
To me, yeah. If they have to replace, if they want to replace the CodeMatter dongle with one that is PQC ready, they need to buy a new one. Yes.
So it's fairly simple.
That's fairly simple. Yeah.
As mentioned before, Steve, 2030, keep in mind that we have today also in many government agencies so-called connector, which decrypt and encrypt. Every German embassy have such kind of connector worldwide, and 2030 they must replace them. So we have some challenges in the market.
Do you think they're as ready as everybody else is?
No, but this is a clear deadline, and the German government will see products at this time, not only some PowerPoints. Yeah?
Okay. Well, as we're in the last few minutes, I'm going to do a very, very quick sum up from my notes that I have here. One is this urgency of PQC migration. As Detler said, as a lot of the reports have come out, these timeframes are now set in stone. You're seeing, the cyber, I've forgotten it, the Cyber Act for 5 years. If you've got products that's going to be connected to something, it has to be proved. So there's very much an urgency for this now. Also, the importance of crypto agility, which people weren't really thinking about a few years ago, now becoming incredibly important. A European harmonized roadmap that needs to be Europe-wide and not individual country driven, which is even more important these days. And finally, from what I picked up certainly from WIBU and SAP, fairly industry-specific solutions that has to be incorporated in there. Would any of you gentlemen like to give a final statement on the encroaching quantum revolution?
So from industry point of view, Infineon, PQC is coming and will be present. So we cannot stop this train. We must jump on this.
we have to switch to PQC, but we don't yet fully understand everything, so there's a lot of research to be done.
Okay. Thomas?
Yeah, we rely on partners like WIBU, to be honest. Yeah, our customers now, they are taking the commercial process in our systems, in what helps and what comes in, which is relevant for the topic I hand over to.
Yeah, and I can repeat that we try to take our customers to the journey, that we involve them early, especially for this migration path, and not necessarily throw away everything, but increasing security levels step by step, using existing rolled out license containers as well. So that's a smooth migration for the software vendors, for the device manufacturers, and for their customers.
Okay, well, thank you very much for participating today, both the audience online, the audience here. Special thank you to Dr. Detlef Hudor, Thomas Devweg, Professor Dr. Müller-Quader. I hope I got that right. You know, it's the English. And obviously, WIBU-SYSTEMS CEO, Oliver Winsen-Reed. Thank you very much. Should you wish to have any questions or you want to talk to anybody, again, I'm talking to the people online as well. If you'd like to put your comments or your questions in, we'll make sure that it reaches the roundtable participants here, and we'll get answers back to you. My thanks to you. This has been the InnoDays 2025 Roundtable. My name's Steve Atkins. Thank you very much.
Thank you very much, Steve, for your moderation, and thank you to all the panelists. Thanks a lot. Thank you for joining InnoDays here in the room and at home at YouTube.
Brilliant. Thank you so much. Again, sorry, I have to be careful what I say now.